In oilseed rape, there are lots of different insect pests that attack the crop. So this means that the farmer has to repeatedly spray. So it's really important for him to recognise, or her to recognise, when there is a problem. So that involves really understanding when the pest is going to be there, what damage it does, and identify it correctly. Because there are a lot of good natural enemies out there. We call them natural enemies, and they attack the crop pests and provide pest control for free. So if you've got lots of those in the environment, then there's less of a need to spray insecticides. Overuse of insecticides, the same insecticide product, again and again and again, has resulted in build-up of resistance to those products. So if we can help farmers to only use those insecticides when it's absolutely necessary, this will reduce the possibility that insects will build up resistance to those products through time. So the way farmers currently monitor for pests is they have to get out of the Land Rover and they have to walk a transect or a path at least 30 metres into the centre of the crop. Along that path, several plants, probably about 10, should be monitored. So they will beat out the number of insects and count them and then work out an average. So we know that pollen beetles like yellow. If you've ever worn a yellow shirt or got yellow washing out on the line, you get covered in pollen beetles. Pollen beetles like yellow. So we had a yellow trap. But we also looked at what volatiles, what smells that are coming from the plants that they are particularly attracted to. And we identified several key components of that smell and put it into a lure. So now we've got a monitoring trap that's used commercially. Farmers can use that in their crop to more accurately identify when the pollen beetles are moving into the crop. And this piece of equipment here is called a LIDAR. It's like a laser, and the LIDAR points the laser beam into the crop. But here we've got it in the lab, and we've got insects that are flying through this laser beam, if you like. And the beam is detecting, so a detector is detecting disturbances in that beam. And then we take those measurements and we use that with machine learning. And so we're basically teaching the computer, this is a pollen beetle, this is a pest. This is a seed weevil, this is a pest. This is a honeybee, this is good, this is not a pest. So the laser technology will enable us to basically scan the whole field in real time and be able to tell the farmer, you've got this number of insects, but in this place, yes, you've got too many pests, but you've also got too many natural enemies, and those natural enemies will do the job for you. So you don't need to spray insecticides in these areas. It might tell the farmer, yes, you've got too many pests, but right now you've got too many bees in the crop as well, and it's not a good idea to spray at the moment. If our integrated pest management strategy were to be taken on board by farmers, I think the countryside would look very different for a start. We've developed the use of trap crops, which are early flowering oilseed rape plants or turnip rape plants, yellow flowers that flower earlier than the main crop. So you would get a patchwork of yellow flowers with the green crop in the middle. That prevents the main pests from going onto the main crop. So you would get a patchwork of colours in the landscape. We would also advocate using flower-rich field margins to build up the populations of beneficial insects. So I think that could look quite pretty. And also, if we could reduce the number of insecticides that we used, then there would be more insects and biodiversity buzzing around, more food for birds.